A medical researcher needs 6 people to test the effectiveness of an experimental drug. If 13 people have volunteered, in how many ways can 6 people be selected? So who thinks this is a permutation? Who says combination? All right, this would be a combination. And the reason why it's a combination is because each person who gets selected has the same outcome. So go ahead, take a minute and type that in your calculator. All right, question number 2. The Pike Runners Club is participating in a race. There are 8 students running. The top 3 will earn a gold, silver, or bronze. So this will be a permutation because a gold is not the same as a bronze. We got 8 students and 3 medals. Go ahead, type that in your calculator. Okay. Let's look at our note packet. Let's go to page 16 and let's continue practicing what we started yesterday. So probability that it's a boy. So this here is my total. This here is what I use when it's not conditional. Total. Out of 152 people, how many are boys? 100. All right, I want you to go ahead and take a minute. Take about 60 seconds and fill in these 3. This means probability that it's a girl. That's what the G stands for. So this is girl. Likes cats. Likes dogs. All of these are not conditional, which means that they will all be out of 152. So take a minute, answer B, C, and D. All right, how many girls participated in the survey? So there was 52 out of 152. Xavier, how many people said they like cats in total? No, I'm sorry, not Xavier. I'm sorry, King. How many people said they like cats? 73. Leo, how many people said they like dogs? 79. Any questions about those 3? Who agrees with those 3 answers? All right. When we get down to this one, though, it's no longer out of 152. Because what E is saying is cats. This means cats given girl. That's what that means. So I need to first figure out how many girls. And then out of the girls, how many said they like cats? So in total, girls, that was this row. There were 52 girls. So this is going to be over 52. How many of those 52 girls said they like cats? 41. All right. F takes a lot of space. I'm gonna do that one. Well, yeah, let's do it now. This means cats or. This means or. So what you need to figure out is how many cats plus how many boys and subtract the both. That's the only one that has a formula, is when it's faced up like a U. It's an or formula. So looking at your table, in total, how many people said they like cats? So there are 73 people who said they like cats. Plus, there are 100 people who took the survey that were boys. But I got to subtract. So I use these two numbers, but I got to subtract the number that I highlighted pink and yellow, which is 32. Pick up your calculators. Type 73 plus 100 minus 32. You should get 141, and it's over 152. So my answer that I'm looking for is 141 over 152. That's the answer for for F. All right, G is a given. So this means dogs given boys. That's what that means. So I'm not looking out of my population that I'm looking at is boys. How many boys took the survey? So there were 100 boys. And out of those 100 boys, how many said they like dogs? 68. All right, this last one is the overlap. This is going to be out of the total, which is 152. So boys and dogs. So boys and dogs. What number is pink and green? 68. All right, any questions about that? All right, I'm going to give you a minute to go to page 17 and copy down a couple of definitions as we finish up our unit here. Take a minute and copy down the definition of independence at the top of page 17. So one of the questions on the test, you have to determine if they're independent. The most important thing for you to write down is what I have highlighted in green and yellow, because these are the two formulas that we're going to use. So this is how we test for independence in statistics. So if we have the probability of A and B, if that equals the probability of A times the probability of B, that means they're independent. Or if it's a conditional probability, if the probability of A given B is the same as the probability of A, then we can say they are independent. So anyone still writing down these definitions? All right, so let's get started. So let's look at number 3. It says that we have the probability of selecting a purple marble, that should say from a bag, is 0.4. So I'm going to write this off to the side. So probability, let's write this off to the side, of purple is 0.4. That's what it said in the story. Then it says the probability of selecting a big marble from the same bag is 0.55. So probability of big is 0.55. The probability of selecting a marble that is purple and big is 0.3. Excuse me, I'm sorry. My allergies are really acting up. Purple and big is 0.3. So to figure out if these are independent, what we need to figure out is if I multiply these two numbers together, do I get this? So if you take 0.4 times 0.55, is that equal to 0.3? If it's equal, then it's independent. If it's not equal, it's not independent. And that's it. That is your independence test. So pick up your calculator. Take 0.4 times 0.55. So 0.4 times 0.55. You should get 0.22. 0.22 is not equal to 0.3. So that means that these are not independent events, because it wasn't equal. And that would be your answer to number 3. So one does depend on the other. They're not independent. Let's look at question 4. Probability that it rains on Monday is 0.4. So let me write that down. Probability of Monday rain is 0.4. Probability of Tuesday rain is 0.2. So it says rain on Monday is 0.4. Rain on Tuesday is 0.2. Rain on both days is 0.08. So probability of rain on both is 0.8. So what we need to do with our calculator is take this number times this number and see if it equals this. So I want you to pick up your calculators, take 0.4 times 0.2. Does that equal 0.08? And I always put a question mark above it because we don't know that yet. So pick up your calculators and take 0.4 times 0.2. And we got 0.08. So 0.08 does equal 0.08. So the answer is yes. These are independent. Rain on Monday has nothing to do with if it's going to rain on Tuesday. These are independent events. All right. They gave us the formula here. So we need to figure out does this times this equal this? So let's write it out. 2 over 5 times 1 over 4. Does that equal 1 over 25? So go ahead, put that in your calculator. When you multiply these together, you actually get 2 over 20. 2 over 20 is not the same as 1 over 25. So the answer to number, and I know these are kind of close together, is they're not independent. I don't know what event A and B are, but whatever they are, they're not independent. All right, so the probability that you get an A on your math test is 0.75. The probability that you do not get an A on the math test is 0.75. So probability that you do get an A on the math test, can you write down that that is going to be 0.25? And then the probability that you get an A on chemistry, A on chemistry is 0.3. And the probability that you get an A on both is 0.075. So let's go ahead and multiply it out. So what we need to do is we need to figure out is 0.25 times 0.3, does that equal 0.075? So go ahead, pick up your calculator and multiply it together. So we got 0.075 equals 0.075. So it is equal, so it would be a yes. Yes, it is independent. All right, our last test, the formula says that if the probability of A given B is equal to the probability of A, then it's a yes. So we don't need the probability of B. So what we need to figure out is 9 over 20, does that equal 27 over 50? So what I want you to do in your calculators, go ahead and transfer that to a decimal. So I'm going to, in my calculator, I'm going to type in 9 divided by 20, and that is 0.45. And then do the same thing with 27 divided by 50. And that's 0.54. So it's not equal, so it would be not, they're not independent. All right, so tomorrow we're going to do the last page of our notes, page 18, some of those questions, not all of them, and I'm gonna go over your skills check. So use this time to finish up your homework. You should be finished with all 4, honestly, or start working through all 4. And then we will pick up here tomorrow.